Hi guys, welcome to our lesson for today. So today we're going to be looking at solving circle geometry riders, right? Just to quickly explain what riders are, these are just questions that involve a combination of the theorems that we've done under circle geometry. So it's not a new concept, it's just how we call the questions that we solve under circle geometry. So please don't now be thinking it's something that you need to think about and try to solve. No. It's just questions that involve a combination of these theorems. But for now, let's just look at what we need to do for today. So firstly, we know that when it comes to circle geometry, I like it when we separate this based on lines and angles and then cyclic quad, because cyclic quad comes from lines. And then you can talk about the theorems that are involved in having lines, right? Which will be a radius, perpendicularness, a chord, a tangent, and then you can link all of those to theorems. But now we will actually be linking them while trying to solve the questions. Now, hints for solving these riders. Firstly, you need to make sure that you mark all the given information on the diagram. So, for example, when they tell you that in triangle ABC, line AC is equals to AB, as soon as they say that, you quickly go to your diagram and draw a line by AC and AB to show that they are equal to each other, if those are the lines that they are saying are equal, right? And then from there, you then identify how the information links to the theorems available. Now that I have a triangle which has two sides being equal, it then means that the angle C and angle B will be equal to each other. And that theorem has to do with properties of an isosceles triangle, right? So you would then say its angles opposite equal sides. So this is, excuse me, something that they tell you although they don't tell you. So it's like an implicit information that they are suggesting, but you must know it based on the information they have given you. And then from there, I'm saying one more example will be if maybe they tell you that a line is a tangent. This can be linked to a tangent chord theorem when an angle is equals to an angle in the alternate segment. You know how tangent chord theorem looks like. And then also you can think about tangents from the same external point and more, right? One more, I think, property there will be a tangent perpendicular to the radius. So those are just the things I want you to think about. So I don't want you guys to then quickly rush to the questions as soon as you read the statement. No, you read the statement, try and mark those things on your diagram, and then mark additional information that is there based on the markings that you've done because of the given information, right? So this is you thinking about what does a center tell you? What does a line being equal to that line tell you? What does a tangent tell you? What is implied by saying this is a cyclic quadrilateral? So those are questions that you need to be asking yourself. That's what I mean when I say then include your additional information, right? So please make sure you are clear on that. And then the other thing that you will need to do will be to mark this additional information that is linked to these theorems as I showed you with my triangle there. Then from there you quickly go to the questions. You construct a short direct argument. What I mean by this is you guys normally have a list of things that you are mentioning that have nothing to do with what we want you to solve. So you always need to be sure that when I want you to talk about an angle in this triangle, you specifically focus on this triangle. And that will be your short direct argument. And then please remember, when it comes to geometry, monkey see, monkey do does not apply. So because it looks like it, you cannot claim that it is it, right? So it means I must tell you, so you must give me reasons each time. Now let's try and apply all of this into a question. It says here, O is the center of the circle. Already, that's important for me. I am pausing there. Now, about a center, I know that I can think about the radius of the circle. I can think about the angle at the center. I can think about a line passing through the center, which will give me a diameter, and then a semicircle, then a 90-degree angle. You see, so already I'm thinking about those things before I can even go to my questions. I know that A, B, C, D, and E are all points on the circumference, so meaning there might be a cyclic quadrilateral that we're going to think about in terms of this when we group 4 points that lie on the circumference if they form a quadrilateral. Then chords B, E, and C, D produced meet at F. The importance of me saying that these lines are produced is to tell you that you can now think about an exterior angle of either a triangle or of a cyclic quadrilateral, depending on which line is produced. Is it in a triangle or is it in a quadrilateral, right? So that's not just me telling you additional information. No, it's important that I inform you that the lines produced, it simply tells us also, maybe if we were to explain this, right? This means that the line is extended, right? The line is extended. So you extend a line. That's what it means to produce a line. Then angle C is 100 degrees, angle F is 35, and AEB is 55 degrees. So let's look at our diagram and add some additional information that we might know based on this, right? So what exactly do I know here? I know that O is the center of the circle, making the angle A to be 90 degrees. I will give a reason, right? This is a semicircle, right? Angle in a semicircle. Already I know that, right? Based on that, I also know that I can talk about angle E1. If I add it to angle C there, it must give me 180 degrees because this is opposite angles of a cyclic quad. Opposite angles of a cyclic quad are supplementary to each other. You see, so all of this is additional information that I am linking on the theorems that I know based on the given information. First question, we must find the value of A. Immediately, you saw in the previous one that A was already there, which is 90 degrees. Now you just need to state it and give me a reason why you say that is the case, right? So you can see that angle A here will be equals to 90 degrees, and my reason for this will be angles in a semicircle. Right? Angle in a semicircle. Some people prefer saying angle subtended by a diameter, angle opposite a diameter on the circumference. It's really up to you. But as long as you talk about the fact that it's a diameter that's subtending an angle on the circumference, then you can claim that A is 90 degrees. But the actual acceptable reason that we normally use is angles in a semicircle. That will be the 90 degrees, right? And then we also want the value of E1. To find E1, as I said, E1, if I was to maybe highlight this, right, you guys will be using your colors. So quadrilateral BCDE is a cyclic quadrilateral, making E1 and C to be supplementary because they are opposite to one another. Therefore, that will make E1 to be equals to 180 degrees minus 100 degrees, and then your reason will be opposite angles of a cyclic quad. Angles of a cyclic quad. Please just remember that CQ means cyclic quad, right? Hence, I'm using the short version of how we normally say this in geometry. And then you will solve. Your value will be 80 degrees. Now, some people always want to include a reason there. You can't include a reason there because you just applied algebra. So you don't need a reason for 180 degrees minus 100 is equals to 80 degrees. That's just math, right? You only need a reason for something that you claim that we wouldn't have said or that we wouldn't have told you, and then give a reason why you are claiming it. The other angle we need to find is angle D1. So before we can even go to D1, we firstly need to look at where is D1, right? So D1, you can see that this is in triangle FED, right? Or some people say DEF if you follow the alphabets in terms of the alphabetical order, right? Now, for me to find D1, it means I must know what B2 is. Because if I know B2, then I can talk about an exterior angle of a cyclic quad. That's one option. Or I can find what E2 is, which I already know because of E1, and then use sum of angles in a triangle. So it's an either or situation that you can do with this, right? So that's one way that you can do. But I think the second way will be the short one, because to find B2, I will use sum of angles in a triangle BCF, and then use that to find D1. Or I can find first E2 using angles on a straight line, and then find D1 using that. So either or, it's really up to you. So maybe let me take maybe the first method. So to find B, I will say B2 is equals to 180 degrees minus, right, 100 degrees minus 35 degrees. Minus 35 degrees. And then you will then subtract accordingly based on that, right? Whatever value you get here, it will be equal to the same value as that D1 there. So this will simply be, my reason, by the way, is sum of angles in a triangle. Because remember, I need a reason every time. 180 minus 100 is 80, minus 35 will then give me 45 degrees. So therefore, you will then say D1 is equals to 45 degrees, and your reason will be exterior angle of a cyclic quad. And that's how you can then do that, right? So you need to make sure that you understand first, what did I give you? Based on what I gave you, you link it to the theorems that you already have knowledge of, and then mark all of those things on the diagram, and then go to the questions, and you'll be able to solve the questions. Guys, I want us to take a quick ad break. When we come back, we'll look at some more questions where we're going to apply all these theorems that we already know in terms of circle geometry. Please stay tuned. I'll be back just now. Hi guys, welcome back to our lesson. We are still looking at solving circle geometry riders, right? These are just questions that we adapted from past papers just to show you how do we apply all these theorems that we have done under circle geometry. So let's look at one more question, and then at a later stage we'll look at another question that we need to solve. So the question says O is the center of the circle. So remember, I did tell you the points that you can think about based on a center. By the way, we actually call these words things like trigger words. We normally call these trigger words, meaning that they trigger some theorems that are implied yet not really said. You see, so you need to be able to know what they're triggering you to think about, right? So you don't just read it as though it's a novel. No, every important word like a center, quadrilateral, on the circumference, All those things are important because they are telling you something that is implied based on the theorems that we know. Then they say quadrilateral ABCO is drawn with A and C being on the circumference of the circle. And then we know that AB is a tangent. AB is a tangent. Remember when we started, I said this means we must think about the 10 chord theorem, or we can think about tangents from the same external point. But as soon as they introduce another tangent, which is BC, it means that now we can think about tangents from the same external point. Do you see? Being equal to each other. Then the other thing they tell us is D is the midpoint of chord AC, and AD is equals to DC. Now, on all of this, the last thing they tell us is E is the point on the circumference of the circle with center O. So they are just telling us that E lies on the circumference. So if we were to use E, we'll need to consider some things that have to do with it being on the circumference. Now, AC is given to be for 8 centimeters. Now, since D is the midpoint, it makes AD to be equals to 4, and it makes CD to also be equals to 4, right? And then OD is 3, and then the others is X and X plus 4. Now, on the diagram, to apply this, I'm firstly going to go straight to AD and say that is 4 centimeters, and that is 4 centimeters, right? And then you know that OA and OC and EO are all the radii of the circle. They are all going to be equal to each other. So if I find one, I know the others, right? And then what more can I add? The other thing I can add is X plus 4, which is BC, because it's tangents from the same external point, right? Tangents from the same external point. I'm just writing it as tans to say tangents. Now, to calculate with reasons the size of D1, that's the first thing we need to find. We know that as soon as this is equals to that, right? Because they are tangents from the same external point, and AO is equals to OC. It then makes ABCO a kite. So what do we know about a kite? The diagonals intersect at 90 degrees. Or we because that will take us a bit of a while, because we need to first talk about it's a kite. We can simply just say D1 is 90 degrees, and then we say the radius is passes through the midpoint of AC. You remember the radius chord theorem, right? The very first theorem that we did under circle geometry. So I will then say D1 is equals to 90 degrees, and my reason for this will be radius chord theorem, right? Theorem. But then to write it in great detail, you would then say line passing through the midpoint of a chord, right? Or radius passing through the midpoint of the chord. And that's why D1 would be 90 degrees. You can go through the route of proving a kite first. It might just take you a while. Most of the time you'll see that this is 1 mark or 2 marks. Now, we also want the length of OA. Remember, this is the radius of the circle, right? So what I will then do is I know that AD is 4 centimeters, so I will focus in triangle AOD. So I will then say in triangle AOD, I know that I will have AO squared is equals to 4 squared plus 3 squared, right? This is just theorem of Pythagoras. You can see they didn't talk about reasons, because when you talk about theorem of Pythagoras, you don't need reasons. And this will be equals to, this is 16 plus 9, it's 25, and that's AO squared, therefore AO is equals to 5 centimeters. And then the next question is calculate now with reasons the size of A, right? The size of A will also be 90 degrees because the radius is perpendicular to the tangent. So A will be equals to 90 degrees, and this is radius perpendicular to tangent, because we do know that those are tangents and that is a radius. The value of x if x is greater than 1. They just want you to find x. Whatever you get it as, it must be a value that is greater than 1. So what do I know? I know that this is 4 there, right? And then I know that this is 5. I know that this is going to be x there. And then it means EO will then be also 5, making ED to be 2 centimeters there, right? It might not look like it, but because EO is the radius, it will be 5. So I will say in triangle AOB, because it's a right-angled triangle, I will know that x plus 4 all squared is equals to, okay, so it can't be equals because that's not the longer side. So let me just quickly fix it. This is not the hypotenuse side. The hypotenuse will actually be BO, right? So this will be plus the other length, which is 5 squared, and this will be equals to BO, which is x plus 5 all squared. And then you can solve this, right? So it will be x squared plus 8x plus 16 plus 25 equals to x squared plus 10x plus 25. The 25 and the 25 will be 0. The x squared and the x squared will be 0. 8x and 10x will then give me 16 is equals to 10x minus 8x. Therefore, it will then be, lastly, 16 is equals to 2x, then x will be equals to 8. And it is actually greater than 1. Now, just one last question. They say to us, a circle passes through A, B, and E, right? And then this is a parallelogram ABCD. We have a tangent there, which is BC. Now, if we apply all of this that they've given us here, right? We know that AB is equals to AE, right? And C1 is X there. The first question will be, why is B1 also equal to X? And your reason for B1 being equal to X will just be corresponding angles. Corresponding angles because AB is parallel to DE, right? Because we were given that. And then the next question, which will be just 3 more angles that are equal to X and reasons. Firstly, we know that this is equals to X, and that is a tangent, right? BC. So meaning it makes E2 to also be equal to X. So firstly, I will say E2 is X, and this will be 10 chord, right? This will be 10 chord. And then I know also that B2 will be equal to X, and this will be angles opposite equal sides. And then lastly, we need one more angle, which we then will say is E3 because of alternate angles. This will be E3, which is equals to X, and your reason will be alternate angles. And that's what you will then need to do. So firstly, we used the fact that this is 10 chord, and then we found B2, and then from B2 we know we have alternate angles, which gives us E3. And that's how you can then solve these questions. All right, guys, I want us to take a quick break so that we can just freshen up a bit, drink a glass of water, and then when we come back, we'll look at some more questions. Please stay tuned. I'll be back just now. Hi guys, welcome back to our lesson. So as I did say that we are still looking at the concept of solving questions under circle geometry, right? These are questions we adapted from past papers just to show you how do we apply these theorems. So let's just jump right into the next questions that we are going to try and do. So here they say M is the center of the circle SVQR. So that simply tells us that we are dealing with a cyclic quadrilateral because 4 points are on the circumference, right? You might think about it, although it might not be a four-sided shape, but if we have 4 points, then we can think about cyclic quad. Having equal chords, which is SV and QR, right? That tells us we can think about an isosceles triangle somewhere. Now what we know also is that RP is equals to QP, which RP and QP, I mean, are the tangents, not that they are equal, right? They are the tangents at R and Q respectively. And then lastly, we know that RPQ is equals to 70 degrees because of these tangents. Now, in a diagram, this is what our diagram will look like. Now, I just want to add a few things here, right? That PQ will be equals to PR because they are tangents from the same external point. Then telling us that angle R2 is equals to angle Q2, which because is an isosceles triangle. But remember, you don't say such things, right? You say angles opposite equal sides. And then even in the small shapes, we can talk about this being equals to that because it is the radii, and also that being equals to, I'm just going to erase one because they are all radii, so they are all equal to each other, not three lines. So all these lines are all equal to each other, but it doesn't tell us much about the angles maybe that we are dealing with there. Now, let me quickly add the information that we added, and then we will answer the questions. That's all that matters for now. Then the first question wants us to find the value of R2. Now to find R2, we know we're going to use the sum of angles in a triangle. Since R2 is equals to Q2, that will be then our starting point, right? So I will start by saying R2 is equals to Q2, and this is because it's angles opposite equal tangents, right? You will specifically say equal tangents. And then you will then say, we know that 2R2 plus 70 degrees must be equal to 180 degrees, which will be sum of angles in a triangle. Right? And therefore I will find my 2R2 to be equals to 180 minus 70, which will be 110 degrees. You divide both sides by 2, then R2 will then be equals to 55 degrees. And that's how you can find R2. So the first golden thing to think about here is what is the relationship of R2 with R1, because the only value I have is 70 degrees. And when I say I want the size, it means you must use the given value. So you can't go into any other shape other than this particular shape. Then also we need to find Q1. Now to find Q1, we know that this is going to be 55 degrees, we said, R2, and also Q2 will be 55 degrees. But we know that Q1 plus Q2 is 90 degrees. So that's where we're going to start. Q1 plus Q2 is equals to 90 degrees. My reason will be radius perpendicular to tangent. Please don't ever say Q1 plus 2 like this, because this simply means it's Q3. It has nothing to do with you adding Q1 and Q2, right? So these are just some of the mistakes that some people make based on just trying to shorten things and do things quicker, you see. So please make sure you are clear on that. Now we know we found Q2 based on this, right? So I will say Q1 will be plus 55 degrees, which is equals to 90 degrees. Then my Q1 will be equals to 90 degrees minus 55 degrees. Then Q1 will be equals to 35 degrees, right? So that's what we will then have as Q1. Now, to find M2, firstly, we need to find what M1 is, because that's the only angle we can find. The mistake that some people make, since all of these are radii, they then assume that these isosceles triangles, which is QMR, is the same as the isosceles triangle VSM, which is not the case. Yes, they have equal sides, but they are not necessarily the same thing. You can't use them across in that way, right? But what do we know in these two shapes? We know that equal chords subtend equal angles at the center. So this chord and that chord. Let me just erase the lines that we are not using so that it does not confuse you at the end of the day, right? Yes. So I know that those chords are equal, therefore they subtend equal angles. So if I find M2, if I find M1, then I know what M2 is. But please don't say it's vertically opposite, because they are not, right? So firstly, I will then say M1 plus Q1 plus R1 is equals to 180 degrees, right? This is just simply sum of angles in a triangle, right? Based on this, I will then say, but before I can claim this, I will firstly say Q1 is equals to R1, because this is angles opposite equal sides, right? Equal sides. And this will then be what I will use to try and find the value of M1, right? Because I know what Q1 is, which was 35. It also makes R1 to also be 35. Then I can find M1 based on that, right? So I will then say M1 will be equals to 180 degrees minus 35 minus 35 degrees, which will be the same as 110 degrees. So therefore, M2 will be equals to 110 degrees, and your reason will be equal chords subtend equal angles at the center. Right, so that's what you will then do. Guys, I'm just trying to shorten the reasons, but I hope you can then see them, right? And then also, they give us another shape now which has O being the center of the circle. CDE is a tangent to the circle. Guys, I won't lie to you. You see, I get very excited every time I see the word tangent, because there's a lot you can talk about when it comes to a tangent. There's a lot you can talk about when it comes to a center, you see. So these, I think, even a cyclic quad, those three terms are the ones that really excite me, especially when I'm doing circle geometry, because then I know there's a lot of things I can think about. Now, on this shape here, they told us that that is the center, which is O, CDE is the tangent, then BD bisects ABC, right? So BD bisects ABC, meaning B1 is equals to B2. They don't look like it. This is the emphasis of, because it looks like it, it does not make it what you think it is, unless you are told, you see. So no one can claim that these angles are equal by just looking at them, because they don't look like they are equal. But because I told you, then you can claim that they are equal. And then they firstly want us to prove why BC is parallel to OD, and they also do not look like they are parallel, right? What they want us to do here will be to either talk about an exterior angle of the shape, maybe, that we can try and talk about if there is an exterior angle, because that will lead us talking about either corresponding angles, alternate angles, not co-interior, because we don't have values, you see. So that's why I'm saying either you consider the exterior. And I can see that O1 is actually equals to B1 plus D2. Firstly, we know that B1 is X, right? So I will then quickly say B1 is equals to D1, and this is equals to X, and this will be angles opposite equal sides, right? And then I also know that O1 will be equals to 2x, right? This will be 2x. You can either say it's because of angle at the center twice angle at the circumference, or you can say exterior angle of a triangle, right? So it's an either or situation. It can be exterior angle of a triangle, or it can be angle at center twice the angle at the circumference. So please do consider those. And then from there, I know that it means that B is equals to B1 plus B2, which will be the same as 2x, and therefore I will then say that this is, the lines are parallel. BC is parallel to OD, and my reason for this will be converse corresponding angles. Converse corresponding angles, right? Converse means you did not know that the lines are parallel, but based on the corresponding angles being equal, it then makes them to be parallel. And that's what you will then need to do here, right? So you please need to make sure that you understand what this means, right? To prove something is not necessarily what you are required to do. That's a conclusion that you're gonna draw after you prove what makes it to be what we want you to prove. So if I say prove it's a cyclic quad, I'm actually asking you to prove what makes a quadrilateral to be called a cyclic quadrilateral, and then you can claim from there. So that's what you please need to make sure you are clear about. Guys, I want us to take one last ad break. When we come back, we'll then look at other questions that we're going to do, and then you guys will also know for sure that now you understand what we've done. But for now, let's take a quick ad break. I'll be back just now. Hi guys, welcome back to our lesson. So now we are in our last segment, right? So here we're going to look at one more question that has to do with all these theorems that we have applied. So you need to make sure that you are clear, guys. When I ask you, or when a question asks you to find a value maybe in terms of something, it simply tells you that the answer does not necessarily have to be that something. It can be in terms of it, right? So that's something I want you to think about as we are going to this question, because there's where we're going to be talking about that. And I need you to please be clear on that. But let's just look at the question. So the question says, O is the center of a bigger circle, all right? Make that circle bigger, right? There's a bigger circle and a smaller circle. And then O is the center of the bigger circle, and also it lies on the circumference of the smaller circle. We also know that OW, VU, I'm glad that U comes after, because then it will be weird to pronounce it. And then are points on the circumference of the smaller circle. TSVU are points on the circumference of the bigger circle. It's just to tell us that the cyclic quads that we can think about. Please remember, I've been saying that. Now, if we look at our diagram, what do we know here? We know that since this is the center, this will be an angle at the circumference, which is half the angle at the center because they are subtended by the same chord. You see, so already I know something. That tells me this is x, right? If that is x, it tells me S1 is also x, and then I can find other nice angles on this. But for now, let's look at exactly what do they want us to do and use these things for. The first question wants us to name the 4 other angles that are equals to x, and we give reasons why they are equals to x. So the first one I already said was V3, right? V3 will be equals to x, and this will be angle at center 2 times angle at circumference, right? I know you guys can complete that. And then based on us knowing V3 to be x, it then also makes S1 to also be equals to x, and this will be angles on same segment, right? Same segment, meaning they are subtended by the same chord. Some people use those terms. And then also, if S1 is equals to x and V3 is x, in the smaller triangle, we know that V3 will be equals to W1 because it's angles on the same segment as well, right? So it will be W1 as well, which is equals to x, and the reason will also be angles on same segment. Same segment. Now I need one more angle because they said we need 4 of these angles, right? So what do we know? We know that if I have V3 as x, W1 as x, S1 as x as well, then I must try and link all of these to the other shapes maybe so that I can find this angle here. So what this will then be, because I'm just quickly trying to see where this will be. So since that is x, and that is x, and I know these are same segment as well, and this one and that one are also same segment, but they don't tell me anything about x. Therefore, based on that, we can then just say O1, we know that it is equals to V3 and the whole of U, right? Because it's an exterior angle of a triangle. So that simply makes angle U to also be equals to x, and your reason will just be exterior angle of triangle. Now I'm going to specifically say which triangle so that you are clear, right? OVU. And that's what you will need to do. Just to show you how it became x, it's because you will say that O1 is equals to V3 plus U, right? O1 is 2x, V3 is x plus U, and then you solve for U. You can see it will be 2x minus x. So this is just how we found x, not necessarily that I'm saying you must make it part of your working out. Some people can, rather they prefer to do it so that they can see it. It's really up to you. At the end, I want 1, 2, 3, 4 angles to be equals to x with their reasons, not equals to something in terms of. But now they want us to prove that WS is equals to WV, right? WS is equals to WV. What they are actually asking us to prove, which is RTP, I will say required to prove, is that S2 is equals to V1. That's what they are actually asking you to do. Not that they want you to prove the lines are equal. No, that's a conclusion you're gonna draw after proving what I'm saying they are requiring us to actually prove. Now, what do I know so far? I know that S1 plus S2 is equals to 90 degrees, right? And my reason for this will be angle in a semicircle, right? Semicircle, because by the way, in the bigger triangle, in the bigger circle, TV is actually the diameter, right, of that particular shape. So S1 plus that will be 90, but I know S1 to be X, right, because we found it from the previous one. So this will be S2 is equals to 90 degrees minus X. So it means I must find V1 to be 90 degrees minus X. In that particular triangle, so what do I know about V1? I know that I can try and say V1 here, if I want to try and find it using the value of W3, right? Because W3, we can find it based on this angle here, which is O2, right? So I will then say I know that W3 plus, right, S2 plus V1 must be equals to 180 degrees. And this will be sum of angles in a triangle. W3 will always be, because this is, O2 is 180 degrees minus 2x. And W2 will be equals to that. It makes W3 to be equals to 2x, do you see? Because it will be 180 minus that, so it will just be positive 2x. So this will be 2x plus S2, which will be 90 degrees minus x, plus V1, and this is equals to 180 degrees. So 2x minus x is positive x. 180 minus 90 will be 90, so V1 will be equals to 90 degrees minus x. So do you see, now I've proven what I told you that they are actually wanting us to prove. Therefore, I will then say WS is equals to WV, and my reason for this will be sides opposite equal angles. Sides opposite equal angles. And then the last question that we actually would need to do here, just so that, because I think I took it out, will be the one where we actually find the value of W2 in terms of x, which I think we might have skipped. I actually did take it out. So you actually would find W2. That's actually a question, but I did it as part of the working out. That's where the 2x comes from. So please make sure you are clear on that. So guys, all of what I've done is just to apply what you guys already know. So just make sure, one, you mark what you are given, you go back to the diagram and mark what is known based on what you are given, and then attempt the questions. Guys, that's all from me. I hope you managed to enjoy and learn something and revise as well with me. But from me to you, remember, mathematics is food for the soul. Until next time.